This is Advanced Math 2.2 notes. Long title for today: Solving Rational Equations and Negative Exponential Equations. Okay, solving rational equations and negative exponential equations. All right, solve. Number 1, 14 over x minus 6 equals 1/2 plus 6 over x minus 8. Okay, so we talked yesterday about restrictions. If you have a variable in your denominator, you need to first find your restrictions, otherwise known as your domain. What can x not equal on this fraction? 6, because 6 minus 6 is 0. And what can it not equal in this fraction? 8, because 8 minus 8 is 0. All right, and that is 2 by itself. Remember, when there's no variable, that one has no restriction because there's no variable in the denominator. So 2 is not a restriction because 2 by itself is never going to equal 0. Okay, so we clear, just like we would a complex fraction because there's an equal sign, we clear everything by multiplying by the common denominator. Now, a common mistake kids make is they'll say, oh, my denominator is x minus 6, x minus 8, which is part of it, but they've forgotten the 2. The 2 is there as well. 2, x minus 6, x minus 8, 2, x minus 6, x minus 8. All right, I am going to go through and reduce. The x minus 6's I can see are going to cross off. That leaves me with the 14 times 2 on the outside. I'm going to address that first. 14 times 2 is 28. Parentheses, the x minus 8 that is left. I'll distribute that later. Equals 1/2 crosses out, leaving me with x minus 6 times x minus 8. I will have to do double distribution here. Again, I'll do that later. Plus x minus 8 reduces, leaving me with 6 times 2, which is 12, times the quantity of x minus 6. I'll distribute on the next step. Okay, I can see where there's going to be a lot going on. I'm going to distribute there, double distribute here, and distribute the 12 there. Okay, what does that give me? 28x take away 224 equals, go ahead and do your double distribution there. If you do it in 2 steps, that's perfectly fine, but I know that I'm going to get x squared minus 8x minus 6x is negative 14x, and negative 6 and negative 8 is positive 48, plus 12x minus 72. I can see that I have cleaning up on this side to do. This side there's nothing, so I'm just going to leave it. 28x minus 224 equals x squared. Those right there are like terms, leaving me with negative 2x. 48 and negative 72 are like terms, leaving me with negative 24. Now I can see I'm solving. Now if this x squared was not there and I just had this to solve, That would be a typical two-step equation. Move the x's to one side, constants to the other, divide, reduce, and you're good. Once you throw an x squared in there, these are the ones where you want to get everything to one side so we can get it equal to 0, then factor and solve using the zero product property. So, do we want to move everything to the right or everything to the left? I'm hoping you can recognize, technically you can move it either way, but I want to move everything to the right so I can leave my leading coefficient positive. Because when I factor, it's easier to factor if the x squared is positive. So I'm choosing to move everything to the right. 0 equals x squared minus 30x plus 200. All right, those are some big numbers to factor. Okay, so if I cover the zeros, I know that 2 times 1, negative 2 times negative 1 is 2, and negative 2 plus negative 1 is negative 3. So I'm going to go with the 2, 1 first, x squared, or x and x. 2 and 1 would be 20 and 10. And I know it's going to be minus and minus because this tells me they have to be the same. And in order to be the same and add up to a negative, they'd have to be minus, minus. So let's check. Negative 20x, negative 10x adds up to the negative 30. So we are good. You use a zero product by setting both of these equal to 0. I'm hoping most of you can do that in your head. X equals 20, comma 10. And before we say we're good, check it to your restrictions. Don't forget that, unfortunately, sometimes on tests, I'll have kids do all the work correctly. They even have the restrictions written down. And then they get the answer, and the answer is one of the restrictions, but they forget to check it. And they put the answer in the answer column, and unfortunately, it's wrong. And when I check your work on the test, I see that, but you never double checked it, so I still have to mark it wrong. In this case, we're good, because the restrictions weren't part of my answer, so both answers are okay. If 10 was one of my restrictions, I'd say my answer is only 20. If 20 was one of my restrictions, then I'd say my answer is only 10. If these were both my restrictions, then I would say no real solution. Okay, number 2. Here's the negative exponents. 3x to the negative 2 minus 10x to the negative 1 plus 8 equals 0. Okay, we talked last unit about how to deal with negative exponents. I cannot make one big fraction because there are 3 separate terms. So 3 over x squared minus 10 over x plus 8 over 1 equals 0. I do have a restriction here because I have variables in the denominator. I have an x squared here, an x here, and a 1 here. That one has no restriction, the 1. These two have the same restriction, x cannot equal 0. 10 over 0 is undefined. 3 over 0 squared is 3 over 0, which is still undefined. So 0 is my only restriction. Multiply everything by the common denominator, which is x squared. Reduce 3 minus reduce 10x plus 8x squared equals 0. Now, I've talked to you guys before about factoring backwards. I said if it's backwards, leave it and factor. But because this is backwards, but my x squared, my 8x squared is positive, it is okay to regroup, and I would actually suggest regrouping. But if that was a negative 8x squared, I would leave it and factor backwards. Positive 8x squared minus 10x plus 3. And again, I can do that because that guy's positive. Double bubble, so we're going to use zero product property. You can hit pause, factor on your own, and then hit play and see if you've got it. Okay, I have 2x minus 1 times 4x minus 3. I can see here that 2x times 4x is 8x squared. That multiplies to positive 3. Negative 4x, negative 6x is the negative 10x. All the factoring that we did last unit we will be using for this unit. All right, 2x minus 1 equals 0. 4x minus 3 equals 0. Solve each one, add, divide, 1/2 and positive 3/4. Neither of these answers are part of our only restriction was 0. 0 didn't come up, so both of these answers are good, and we're ready to move on. Okay, number 3. I'm going to give you a heads up right now. This is a difficult one that you really want to make sure you're paying attention to, and come in ready to ask questions our next class day, because this is one that's on the test and that kids typically mess up. All right, 1 over x plus 2 quantity squared plus 1 over x plus 2 minus 6 equals 0. Okay, let's look for our restrictions first. What can x not equal? Okay, this 6 is over 1. There's no restriction there. What's going to make this denominator 0? This one right here. Negative 2, because negative 2 plus 2 is 0, and 1 over 0 is undefined. What about this one? It's also negative 2, because negative 2 plus 2 is 0. 0 squared is still 0, and 1 over 0 is undefined. So this is my only restriction. Okay. Now, what is the common denominator? X plus 2 quantity squared. Okay, reduce 1 plus, sorry, I forgot to put my squareds there. If that was bothering anyone, you're like, oh, what is she doing? It's just I went too fast and I forgot to write them, and I will put them in now. X plus 2 quantity squared on all of them. Squared, squared, and squared. Okay, next one. 1 set reduces, leaving me with an x plus 2. Now I'm going to write it a specific way, and I'm writing it this way only because I know what I'm trying to get at the end, but I will give you tips as I move forward on how to recognize to do this. All right, so I reduced 1 set. I left the 1 on the outside, parentheses, x plus 2 to the first power, because 1 set reduced, minus, nothing reduces, 6 parentheses, x plus 2 quantity squared, equals, this multiplies out to 0. All right, why did I write it this specific way, leaving that in parentheses when with the 1 on the outside? Because I'm hoping you recognize that this is a substitution problem. Now, it's a definite on the test, and you're probably thinking, oh, there's no way I'm going to recognize that. We will do more. We'll do some in class, our next class day. We'll do quite a few of these on our classwork. But how do you recognize these on the test? When you see this fraction, and can you see that this is x plus 2, and this is the same thing but squared? Know that's going to be a substitution problem. Now, it might not be x plus 2. It might be x minus 5 and x minus 5 squared, or x plus 7 and x plus 7 squared. When you see this pattern going on, know it's going to be a substitution problem, which means, say this was a 3, kids are tempted to distribute. Oh, 3x plus 6. Don't distribute. Leave it like this. So when you see it this way, it's easy to say, oh, I'm going to let w equal x plus 2, giving me 1 plus 1w minus 6w squared equals 0. 1 plus w minus 6w squared equals 0. Now, Those of you that can factor without substitution, go for it. You do not need to use substitution. It's backwards, and my w squared's negative, so I'm going to leave him backwards. If you want to regroup it and divide both sides by a negative, you can. I'm just going to leave it backwards. 1 and 1. I can use 6 and 1 or 3 and 2. I'm going to try 3, 2 first. 3w, 2w. That multiplies to 6w squared. Because this is negative, I can tell my two signs are going to be different, either plus minus or minus plus. If I did a minus plus, that's going to give me a negative 3w, a positive 2w, which would be negative, not positive 1. So I can tell this is going to be a positive, this is going to be a negative. 1 plus 3w, 1 minus 2w. And now you can solve or you can plug back in and solve. It does not matter. Some kids will solve for w and then plug the w back in. I'm going to plug it in now just because that's where we typically did it in the past when we were just factoring. 1 plus 3 blank exaggerated parentheses. 1 minus 2 blank exaggerated parentheses. What goes in the blank where the w used to be? The x plus 2. You see how that works? 1 plus 3w is x plus 2. 1 minus 2w is x plus 2. All right, 1 plus 3x plus 6. 1 minus 2x minus 4. And again, we're doing this because we're trying to solve and we can't leave nested parentheses anyway. So this is 3x plus 7. And this is negative 2x minus 3. Set them both equal to 0 and solve. Subtract, divide, equals 0. Add, divide, you get negative 7/3 and positive, negative 3/2. Because you add its positive, we divide by the negative 2, it makes it back to a negative, negative 3/2. Oh, our restriction is negative 2. Which is okay with our answer because we didn't end up with a negative 2. So this is our solution. Now that's it for this lesson. What I suggest you do is I would try this one again. Like write this down or rewind, write this one down again, cover everything and see if you can get it on your own. Practice recognizing. You can even look at them before class starts and see if you can recognize the ones that are like this. Can you see what I was talking about? X plus 2, x plus 2 squared. X plus 1, the x plus 1 squared. X minus 5, the x minus 5 squared. When you see that pattern, know it's going to be substitution. Now, if you wanted to, do not write on your packet, please. I will be erasing this. If you wanted to, you could do this. 14 over w squared plus 1 over w minus 3 equals 0. If you feel like it'll help you to do it from the get-go and then clear by multiplying everything by w squared, which would give you 14 plus w minus 3w squared. Factor, plug w back in, and then solve. You can do it that way as well. So you decide which way you like better. We will do these together in class on our next class session. That's it for this lesson.